Hey y'all, we're looking at lesson 4.2. We're writing systems of equations still, that's all unit 4 is, and we're now going to write them from tables. So our goal, writing systems of equations from tables. So just like we started writing equations from graphs, we're going to start writing equations from tables. So things we're going to need to be successful: use our Desmos graphing calculator or use your Inspire to calculate y equals mx plus b. Remember that we can, anytime we see a table, to get our equation, we can plug it into Desmos, to the table. And then once we're there, all we need to do is convert to standard. Convert to standard form. I told you that's not going away. Standard form is super important. So let's go ahead and try it out. So for this example, you need to write both of the equations down, and then in order to find the solution, you're going to have to graph it. So if it asks you to find a solution from a table, you'll have to first find the equations or plot the points and then find where they cross. That's also a perfectly okay option. You could just plot all of these points: -4, 6, -1, 3, 2, 0, 5, -3. You could plot those points on the graph and form a line just like that, and then do the same thing for the second one, but in order to find the solution. Or graph the points, plot the points, and then find the equation from there. But in most cases, you're just going to be asked to find the equation specifically in standard form, so go ahead and use Desmos to kind of help you out. Remember, if you are writing a table in Desmos, you then in the second box will write y1 tilde mx1 plus b, and that should give you the following two equations: y equals -x plus 2 and y equals 2x plus 5. You should have gotten an m value of -1 and a b value of 2 for the first equation, and an m value of 2 and a y-intercept or a b value of 5 for the second equation. So now in order to find the solution, let's graph these two equations and then identify where they cross. So I've graphed both my equations. I started with my b value and then used my slope to move over. Remember, this slope is -1, which makes it -1/1, so down and to the right. And this slope is 2, so it's 2/1, which is up and to the right. I graphed this second equation in red and the first one in this gray color with a kind of a teal accent in the back, or turquoise accent. So looking for that solution, where do they cross? Right here they cross. That is at the point -1, 3. So that is going to be my solution, -1, 3. Here comes the little bit more difficult part. We're going to have to convert these equations from slope-intercept form to standard form. Before we start, let's recall a few things about standard form. One, standard form is ax plus by equals c. And our a value can't be negative. Okay, if you want to write that down, I would. A value can't be negative. And then your a value can also not be a fraction or a decimal. It must be a whole number. So let's look at these two equations and make sure that we're good. Put them in standard form. So equation 1, y equals -x plus 2. The first thing I notice is that in front of my x value is just a negative. That means it's -1, and that's not a fraction. So I don't need to multiply by the denominator in this case. But I do need my x and my y to be on the same side, like in standard form here. So I'm going to add x to both sides so my x and y will be on the same side. When I do that, I get x plus y equals 2. Now here's where I'm looking. Is there a negative a value? Do we have a negative a value right here? Well, my a value is now just 1 because there's nothing in front of the x, and it's not negative. So that's my final answer. X plus y equals 2. So I'm going to go ahead and write that down below. X plus y equals 2. Now let's look at equation number 2. Y equals 2x plus 5. Again, I notice in front of my x value, my a value is not a fraction. So I don't need to multiply by my denominator. But I do need to move my x to the same side as my y. I'm going to subtract this time since it's already a positive 2x. So subtract 2x from both sides. When I do that, I get negative 2x plus y equals 5. And someone yesterday asked a great question in one of my classes about why do we put the x first instead of the y? Well, alphabetical order. In standard form, everything's going to be in alphabetical order, and so that's why I keep the x first. It's a great question. Here I notice that my a value is in fact negative. It's negative 2. So to remedy that, I need to multiply everything about my equation by negative 1, and this is going to change all of my signs. So it's going to be negative 1 times all of those numbers, and that's going to get me positive 2x minus y equals negative 5. And now that's my final answer. So I can come down and write that 2x minus y equals negative 5. So sometimes converting to standard form is easier when you don't have a fraction. You don't have to multiply by the denominator. All right, ask your teacher if you have any questions.